I am Mohammed Mohsin Tloom. Now I will explain the socio-economic consideration of our project. It consists of two parts. One is cost estimation of our project, and next is application of our polymeric composite. The application of polymeric composite is discussed earlier in the presentation. Now I explain the cost estimation of the project. This is the here we can see, you can see the cost estimate cost of different chemicals and LDP and rices, and we the dimension of the sheet is here. The density of the sheet is 0.4 gram per centimeter cube, and the mass required for the sheet is 18 gram, and the volume of the sheet is 47.313 centimeter cube. And these are the prices of the raw materials. Next, here in this table you can see the cost of different sheet which we will fabricate. You can see here the cost of rices rise very less as compared to treated rices. The cost of treated rices with choline is higher among all. It's because the cost of choline chloride is highest among all. And as you can see here, as we increase the biomass loading from 10 to 15 to 20, 20 to 30, then their cost is increasing gradually in case of treated rices. While in case of raw rices will decrease. The decrease in rices rise due to as we increase the biomass loading, as usually the mass of LDP is decreased and the cost of LDP is higher as compared to rices grass. The, the cost of 30% rices rise very less as compared to 20, 15, and 20, while the cost of treated prices is greater from 15, 20, and 30 as compared to 10. It is because for their pretreatment, because for pretreatment we require the chemicals where which cost is higher. So this is the cost estimation of our project. Now I will invite Mohammed Skandar to proceed the presentation.
So this was all we did in our research project. Now we have conclusion what we did and what were the main things which we did. Conclusion kindly. So the goal of studying biocomposites is to find renewable and sustainable alternatives to conventional synthetic fibers. The use of biocomposites will reduce waste and pollution. We know that we know that world is going towards sustainable development, sustainable environment, and sustainable renewable sources. So this project can help us to go further towards a sustainable world, as we are trying to achieve two or three sustainable development goals through this project. Number one is affordable and clean energy, which is the sustainable goal number 7. After that, industry, innovation, and infrastructure. As we can produce or fabricate our material at industrial level, so we can achieve this industry innovation and infrastructure sustainable development goal too. After that, we can also achieve responsible consumption and production. We can use our raw material being produced by the lands and from farmers. Mostly rice husk is being used at the present time just for burning purposes. We can use it in this direction, so it can achieve the sustainable development goal number 12, which is responsible consumption and production. After that, what we did was sharpening impact strength test, nano indentation, and FTIR were used for the characterization of raw material and polymeric composite sheets. It was concluded that the strength of treated rice husk increases with age. increases with the increase in fiber content in narrow indentation. Load displacement analysis demonstrates that composite material is not fully elastic and shows slight plastic behavior. By increasing loading of natural fiber, plastic behavior increases, and by decreasing loading, plastic behavior decreases. Chemical pre-treatment of natural fiber softens a composite material and enhances elasticity. Hardness of composite material increases by increasing loading of rices and vice versa. This was the conclusion of our whole research project. After that, we have some recommendations of our project. Kindly next slide. It is recommended for the future that the blend can be modified chemically to further enhance its interfacial adhesion with the polymer matrix. This method might improve the overall strength of the composites caused by the strong interfacial adhesion between the rice husk and polymer matrix. It is also suggested that effects from varying the concentration of fibers in the composite should be investigated. More composites with different proportions of fibers incorporated into the matrix may produce superior composites when compared with the composites analyzed in this study. So this polymeric composite is biodegradable and their fabrication process does not require any drastic conditions as other packaging materials needed, like synthetic polymers need higher temperatures and higher pressures. So we fabricate environmentally friendly packaging material from this research work. This was all about our presentation. Thank you for your time and your hearings. Thank you, slide.